Alright, so here we have the lesson on absolute value equations. We're going to do some algebra today. So absolute value is simply the distance from 0 on a number line. You know, and this is something kids struggle with for every once in a while. So let's talk about the absolute value of, I don't know, -6. And let's just draw a number line, okay? Just draw a number line. The most important number on a number line would be 0. And -6 would be back 3, 4, 5, 6. It'd be about right there. So the distance from here to here is 6. And therefore the absolute value of -6 is simply 6. It's the fact that absolute value is a concept of distance that makes it positive. Alright, solve the equation absolute value of x minus 3 equals 3 by graphing. Okay, so here's what we're going to do. We're going to treat these as two separate equations. So we have two equations. This is how we do it by graphing. One of them is y equals the absolute value of x minus 3, and the other one is simply y equals 3. Now, x minus 3, we have just spent a week doing a parentheses x minus h plus k, and we have spent a week talking about what moms look like. This thing is a V, it's a stinking V. We're going to go right 3. We have an initial slope of the understood 1. So we're going to rise 1, run 1 both ways. Now I'm going to do lots of dots because I'm solving by graphing. When you're solving by graphing, you want things to be clear as to where they intersect. So that is the absolute value of x minus 3. Y equals 3, be thinking about y equals a constant, which is a mom function, horizontal line. It is a horizontal line where y is always, guess what, 3. So now again, I'm going to put lots of dots because I want this line to be as straight as possible. Now, when you're solving by graphing, and that's a big deal, believe it or not, in this class, is solving by graphing. But when you solve by graphing, your solutions happen, I'll say when, graphs intersect. So our graphs intersect here at 0, 3, and over here, which looks to me to be 6, 3. That's the coordinates of the intersection. So, but the when would be the x value. So the solutions are simply x equals 0 and x equals 3. That's how you solve by graphing. I want you to note that when I did the solve by graphing technique, I had two equations, okay? Absolute value always involves two equations, whether you're solving by graphing or algebraically. Alright, solve this one. And by the way, please note we had two solutions here. Let's see what this one looks like. This one shouldn't have any solutions because of what it's asking. So solve the absolute value of x plus 4 minus 1 equals -3 by graphing. I'm going to do that -3 first. That's a horizontal line at -3. It'll be looking something like that. That's y equals -3. Alright, think about your a times x minus h plus k notation you've been learning that form. We're going to go left 4, not right 4. Remember, always opposite of the sign, and then fall 1. I don't know why I put a dot there, but left 4, fall 1. A is the understood 1, rise 1, run 1. And you will notice that this particular graph has no intersections. And since there are no intersections, there are no solutions. Now, here's why. Let's go ahead and do a little bit of algebra. Let's add 1 to both sides. This is saying that the absolute value of x plus 4 is -2. And what that means, if we think about the definition, this means that x plus 4 is -2 units. Or, x plus 4, I had it worded better, but it's saying, let me rewrite it. It says distance is -2. Distance is not allowed to be negative. That's the issue. That's why we had no solutions. All right, solve the equation 2. And what's funny is we could come up with answers for this algebraically. So we have to pay attention to little things like that. Solve the equation twice x minus 2 equals 0 by graphing. And again, we're going to have two equations. Let me type them out so you don't have to deal with my bad handwriting. One of them is that y is 2 times the absolute value of x minus 2. And the other one is simply that y is 0. So two equations. It's always two equations. Y equals 0 is simply the x-axis, because anywhere on the x-axis y has a value of 0. That's an understood concept that a lot of kids struggle with. And 2 times x minus 2 shifts the graph right 2 and has a slope of rise 2, run 1. And notice how many solutions we have here. We have a solution at 2, 0. And we have one solution, but this one is solved when x is 2. One solution. So here's what we've run through so far. We had two solutions, no solution, one solution. And here's the last one. X minus 4 plus 1 is 0. I bet this is a no solution system. This is saying that distance is 0, by the way, which is doable. It is. But if you were to graph this guy right here, you would shift right 4 and up 1, and that's when you'd start drawing your V. And I say this a lot, and I mean it. You don't get great at math until you comprehend what's happening visually on a graph. So again, this was a y equals, and this is also a y equals. Y equals 0 is that x-axis. And we can clearly see that we have no solutions. So how many solutions may an absolute value equation have? It may have 2, 1, or none. And I do want you to note that even when solving by graphing that I involved two equations. All right, solve twice x minus 3 equals 6 algebraically. And I need to amend this a little bit as to what I wrote in this text box. The first step is to isolate absolute value. Then write two equations. Okay, so first isolate absolute value, and then write two equations. For the first equation, drop the bars. For the second equation, change the sign on everything inside. And there's a whole lot of ways to do isolation, but you want absolute value by itself. You know, for the last week we've been pulling numbers out. It might make sense to pull numbers in, or you could do a division of 2, but you want this guy to be all by itself. So the opposite of the understood multiplier is division. And if I do that, I'd have the absolute value of x minus 3 is 3. Now that I have isolated absolute value, I'm going to write two equations. The first one, you just drop the bars. And on the second one, you change the sign on everything inside the bars. So this becomes negative, that becomes positive. And the bars are not there. And not that bad. One-step equations. X is 6 or negative x equals 0. And if negative x is 0 and we divide the negativity out, 0 over anything is still 0. So this one has two algebraic solutions at 6 or 0. And if I want to spend some time graphing it, I would. I don't need to. This question makes sense because it says I have a distance of 6. I don't really need to question anything on that one. It should be fine. Solve the absolute value of 3x minus 4 equals x minus 2. Same deal. These bars are by themselves, so 3x minus 4 is equal to x minus 2. Or change sign, negative 3x plus 4 is equal to x minus 2. All right, x is on one side, numbers on the other. 3x take away x is twice x. Negative 2 plus 4 is 2, and we get that x is 1. Over here, let's just move my x's left. Negative 3x minus x is negative 4x. Negative 2 minus 4 is negative 6. Divide out the negative 4. And again, you can run your videos at like half speed or something if I go too fast, or you can hit the pause button. The truth is it's 3:01 and I want to go home. I'd get 3/2. All right, look at this guy right here. It says distance is negative. No solution. Last page. Solve the absolute value of x minus 3 equals 2x plus 4, both algebraically and graphically. So let's do it algebraically first. Now we're going to write two equations. The first one, we just drop the bars. On the second one, we change, and you can pick either this one to change your signs or that one. I'm just going to do the one on the left because it's small. Or negative x plus 3. You don't have to do both, just one of them, and it works its way out. At least it's supposed to. Alright, moving forward with my life. Let's put my x's on my right this time and my numbers on the left. Negative 3 minus 4 is negative 7. 2x minus x is x. There's an x value. X is negative 7. Over here, I'll move my x's right. 2x plus x is 3x, and 3 minus 4 equals negative 1. That tells me that x is negative 1/3 because we divide the 3 out. Okay. Now it said solve it both algebraically and graphically. So let's see what happens here. Let me go ahead and put the grid on paper. Where is that at? It's under edit somewhere. Grid. There she is. Visible. And let's insert some shapes. Some nice good bars here. Graphically only works if somebody spends time thinking about the equations they throw at you, and I spent absolutely no time on this, so it might be kind of hard to see things as they are. This is a shift right 3, rise 1, run 1 situation. It looks something like that, and I may have to do some erasing. Talk about the absolute value of 2x plus 4, by God, you have to factor that. Becomes twice the absolute value of x plus 2, which is a shift left 2, and then rise 2, run 1. And this is why I'm saying I'm going to have to keep going. In fact, I'm going to run out of room before those things intersect, aren't I? No, I'm not. This way is going to work too. So that v goes that way. There's the intersection there, which is what I came up with, negative 1/3. And the other one's at negative 7. Rise 2, run 1, rise 2, run 1, 2, run 1, 2, run 1, 2, run 1. And let's strike down, be right there. 1, 2, 3, 4, 5, 6, 7. So it worked. Anyways, really quick notes because now it's 3:04 and I need to go home. I got a wife and kids to get to. Sorry.